Hello, everybody, and welcome to another Mystery Box Function Challenge. It's a Friday, so that means the challenge is especially challenging. So in this purple mystery box, there's some math. Your job is to figure out what that is. You can pause the video, click the link in the description to get to this page, and put in as many numbers as you need to figure out what's inside. See how they're transformed as they come out. Use that information to determine the mystery math. When you've got it, come on back and see if you get what I get. All right, let's begin on this one with a 0. Okay, so 0 gives us 0. We've seen that many, many times. How about a 1? Now that number is starting to look familiar to me. Is it looking familiar to you? I'm going to put in a 2 next. So we've seen enough of the sine and the cosine functions that I'm starting to recognize these long decimals. So already I'm thinking trig function. Let's put in an approximation of pi here and see what we get. Aha! So we're basically at 0. So let's think about which function this could be. So on the unit circle here, where our x is the angle of this line that kind of traces its way around the circle. So at 0, the coordinates are 1, 0, and the cosine is the measure of the x coordinate, and the sine is the measure of the y. We start at 0, and then by the time we get to pi, which is all the way around over here, we're at 0 again. So this makes sense that this is sine. I wonder what else is going on here, though, because we've seen sine of x before, and so far this just looks like sine of x. But this is a challenge function. Maybe we ought to put in some negative numbers and see what's going on that way. So let's put in a -1. Oh, that is not what I expected. If you're going in the negative direction, the sign should go down here. So that's different. Let's put in a -1.5 because that's pretty close to pi over 2. Okay, and let's put in a negative pi. So it looks like we have two identical little humps there that are parts of the sine function. What happens if we continue on to the right? Let's put in, I'm going to put in a 4, and a 5. I'm going to put in a value that's close to 2 pi, 6.28. Oh my goodness. So it looks like we're getting, it does look periodic, right? Because the same thing keeps happening. We never go below the x-axis. We just go hump, hump, hump all the way along, and I'm assuming this is going to continue. So I guess that is the challenge of this part. I think we're on the right track with sine. What could do this, though? Do you have some ideas about that? We're not seeing any negative values, so the thing that pops into my head is absolute value. Although, are we taking the sine of the absolute value of x? Because then you could put in the negative numbers, and then you just get that part. But that doesn't make sense, right? Because the sine of let's say, the sine of 3 pi over 2, that's a positive number that you're putting in, and you would get a negative number out. So that doesn't make sense that it would be the sine of the absolute value of x. It's not the inputs that matter whether they're negative. It's the outputs that are negative, never negative. So maybe this is actually, let me write this down, the absolute value of the sine of x. So in that case, let's say 3 pi over 2, that should give us a -1, but it gives us a +1, and that's about right here. I think that would do it. So I'm pretty confident, actually, that this is the absolute value of the sine of x. It's really the sine function, but instead of going down here, it just reflects it up like an absolute value would do. And instead of going down here, it reflects it up. Let's see if we're right. Yes, absolute value of the sine of x. And let's graph that. It's an interesting graph. And there it is, just those little portions of the sine curve bouncing along on the positive side of the x-axis. Well, how did that go for you? Was that pretty challenging? Were you at least in the ballpark of trigonometry? Let me know. Thanks, everybody.